Okay, on this one we are going to be computing conditional probability to make an inference, and that's the key word here. We're going to make an inference or draw a conclusion by using a two-way frequency table. This is basically the exact same as the problems we were doing on the last video, except now we got one more piece there at the end. So, on this first problem, we've got 150 patients that are testing a new medication. Some tried the new medication and some took the old medication. The results are reported in the following two-way frequency table. So on this side, we've got old versus new medication, and up top, we've got improvement versus non-improvement. And the purpose of this is basically going to be to figure out if there is like a purpose, or like if the new medication is actually working. So, one patient is chosen at random from the group. Complete the following. Write your answers as decimals. What is the probability that the patient showed improvement? Well, to do this, we got to do the same thing before. Win over possible. So we got to figure out what our win would be on this one. Well, a win would be improvement, and we need to find the probability of that person improving. So in general, our improvement column was right here, 57 and 39. If we add those together, we get 96. That means our win, oops, I messed up, 96. Our win would be 96. Out of how many possible? Well, in general, there was 150 patients. So that would be how many patients would be possible to be chosen. So 150. So 96 divided by 150, that's going to be equal to 0.64. And I don't think I had to round that, so I think that was exactly 0.64, but you'd have to check on that one. Letter B, it says find the probability that the patient showed improvement, and in this case we have a given that he took the new medication. So we're just talking about people now that took the new medication. So let me erase this. New medication only, that's the given, so we're only going to deal with those two bottom numbers. What's the probability that the patient showed improvement? Well, there's 39 of those that I've shaded or that I've highlighted. 39 of those have shown improvement over a total of, let's see, 60 total patients that were in the shaded region there. Those are just the ones, again, it says given that we use the new medication. So that's why I only went out of 60 on that one. If I divide those up, I get 0.65. Now, before we move on to the next question, we need to talk about these two. 0.064 and 0.065. When we're talking about percentages, those are pretty similar percentages. They're not percentages, but they're decimals. But 64% and 65% are pretty much the same. So let's talk about what the problems were asking. The first one was asking, just in general, if patients were showing improvement. On the second one, it says, these are just the ones that got the new medication. Were they showing improvement? Well, I find that they're pretty similar between these two. So if you're making a judgment call, if you're making an inference here, you would say there's really not that much of an improvement if you use the new medication. These percentages are pretty close still. So that's what actually letter C is asking. Is there evidence that a patient... Sorry, let me do this quick. Is there evidence that a patient who takes the new medication is more likely to show improvement than a randomly chosen patient from the group? It's basically asking us to compare our first two problems. Now, personally, I would say no, because the probability found in part B was about the same as the probability in part A. So I wouldn't say that the new medication is more likely to show improvement. Let's go on to the next one. The next one says we have a driver's test. Some of these students passed the driver's test and some of them failed the test. Some of these students took the driving test class and some did not take the class. And we're going to be comparing these as well. So we're going to find the probability that the teenager passed the test. Well, we're talking about all students here, and we're going to figure out the probability that they passed. How many students passed the test? Well, we had 36 and 21 that passed the test, right in this column right here, 36 and 21. So that would make 57 students. If you add those together, 57 of them passed the test. Out of how many? 150, I think was the number that it gave us, right? Yep, 150 teenagers. If you divide those, we're going to keep them as a decimal like it says to, we will get 0.38 or 38% of students pass the test. That's pretty low. Let's continue with B. It says find the probability that a teenager passed the test given, we have a given here, that they took the class. So if I'm talking about students that have taken the class, let me erase this for a second. Students that have taken the class, that would be these students right there. So these are the only ones we can talk about because those were the given ones. Those were the given students. Those are the only ones we're worried about right now. How many of them passed? Well, 36 of them did. Out of how many? 36 plus 24 is 60. 36 divided by 60 is 0.6, or 60%. So question C here is asking us again to compare those. Is there evidence that a teenager who takes the class is more likely to pass the test than a randomly chosen teenager from the group? You're going to have to say yes, because look at the difference between these. This is just randomly selected from all of the students. 38% of the people passed. But given that we took the test, that bumped it up all the way to 60%. That's more than half. So for this one, I would say yes, absolutely, because the probability found in part B is much greater than the probability found in part A. So once you go through those, you're going to have to make kind of a judgment call and